Okay, there's one more thing that we need to do for this list to be truly useful, and that's to actually add a remove method. So otherwise, we can add things, and that's cool. This thing can grow, and it grows very efficiently, right? Because there were no loops involved in adding. There's just a few constant steps, regardless of how big the list was. So that's great, but we also probably want to clean things up efficiently. So let's create a remove method. And what we'll do is we'll just say, hey, you know what? I'm just worried about this object reference. So if I happen to find that this reference exists in the list, I will just remove that reference from the list. So I'll take away that node. Okay. So it's going to be your job to fill this in, actually. And if you get stuck, I want you to talk on Discord and things like that, since we're doing this asynchronously. But let me sketch it out. Okay, so let's say, for example, that I wanted to remove 200 from this list. Okay. So what I would do is start at the beginning, and loop through until I find what I'm trying to remove. Okay, so let's say that I find I'm trying to remove a reference to this 200 wrapper. Okay. So I start at the head. I keep walking, and let's say I find this. Okay. Well, it's like somehow I have to back up and then reassign this next arrow here to point to the next thing. Okay. But I can't go back. That's the thing. I can't just go back. So somehow I'm going to have to remember. So I'm going to have to really have two pointers. One to this current node. So I'll just call this, I don't know, node. And I'm also going to need to maintain a pointer to the last one that I saw, right? So, and then really the formula that I need to say is that last next should be reassigned to node next. And if I do that, I circumvent this arrow here, right? And then I'm done. But the trick is you need to maintain this last pointer as you go along, okay? Maybe I'll get you started with just a little bit here, because there's one special case, right? So if the thing I'm trying to remove happens to be the very first element, so if I say if the object happens to be in the head's, okay, so I guess I should say first, if the head is not null. Okay, if the head is null, then I might as well not even do anything. Okay, so this void method does nothing if I ask it to remove an object that doesn't exist. So I'm only going to remove objects that exist. And if the list is empty, then there's, okay, it must not exist in it. All right. But if it's not empty and the head does exist, then I find that the head actually contains the object that I'm trying to remove. Well, then what I should do, it's actually quite simple. I'll just say head equals head next. Okay, so I'll just move along. I'll say, okay, look, you wanted to remove 371. I'm just going to make the head now point to what 371 pointed to, which is 174. Okay. So that's pretty simple. But the more complicated case that you actually need a loop for comes along and happens when the object might be somewhere in the middle. So if you find it, so you need to maintain two pointers, one to the current node that you're on, the other one to the last one. And if you find it, you need to then do this reassignment here. Okay, so I'm going to let you do that, and then we will have a fully featured linked list. And that is something that we will build on with many variations over the next few weeks. So give that a shot, and again, ask if you have questions.